This video we're going to look at this counter circuit, and the counter has two inputs. We're going to kind of see that this car sensor, this is a parking lot example, that this thing that senses the car goes to the up input, and each time that goes from off to on, we're going to add 1 to the value in the cars. If we want to clear the count, we've got that capability. And then we've got the count complete bit that says when I get to this number, this set point, I'll turn on. So I think it's easier if we just first take a look at this operating, and we'll see. So currently we see there is a value of 2 on this counter, and I'm going to push X1 on the wood trainer, and you see it just went to 3. Push it again, X1 is on, we went to 4, 5. Now during that time, the counter is not complete because it hasn't gotten to 12. So we're going to look at that. We'll go to 6, 7, I can count faster, 10, 11, and now from off to on we'll see X1 transition, and at that point we get to 12 and we see CT1 is on. That's a status bit, or just a bit. The count, cars in the lot, is 12, and we're using that to turn on the red light on the trainer that says we're full. Now to understand counters better, or any instruction, you can double click the instruction and choose help. So we choose help. Up comes the help screen, and we can see in here that it tells us the definition. That's probably the best part. This paragraph answers the biggest question of how the instruction works. And it says, when enabled, that means that rung is true, that first one, that up. A count instruction counts up or down, depending on what settings we pick, until it reaches the set point, in our case 12. The counter counts in response to transitions from off to on of the enabling rung. If the user selects count up and down, it does something else. The counter count is held in the register in the current value field. That's right here, CTD1. When it reaches the set point, the complete bit is turned on and turned off when the rung is reset or it's less than. Then in the help file it tells us, hey, in box number 1, you need to put a CT memory followed by a number, 1 through whatever the max is. Set point, you need to either use a constant, that's what we're using. You could use a data memory address like DSDD, and then the machine could look there. We often see this more common in the field, then they can use a touch screen to change how many parts they want to make. In this case, we'd be stuck at 3 unless somebody reprogrammed it. It then takes that same number, CT1, and says I'll use counter data 1 for this application, and the complete bit is the same as that counter number. So here we have an example in the help file. It says in the following program, after C1 makes an off transition 3 times, the CT1 counts up and the counter status bit is turned on. Notice they call the status bit the complete bit. Now these are just used because this is just an example. There's something turning on C1 and 2 in this example, but we're not concerned with that. It's just whatever the input. This is the enable rung, they call it, as well as the up. And you see what happens is if we draw a vertical line here, the counter is at 0. Upon going from off to on, we go to the count of 1. When the input goes from on to off, it's ignored. Next time it goes from off to on, we get the count of 2. and the same thing with 3. Right at that time, CT1 turns on, just like our parking lot full. Okay? Now C2 resets it, so as soon as C2, that event happens, notice the count went to 0. And they show, should we get a count during that time, it'll be ignored. So these example programs explain how they work. Remember, we got this just through the help file. You can also search things in here as well. So going back to our example, we see the car sensor is there, and now I'm going to use X3. That cleared the count, and you see the parking lot is back open as we add new ones. To add an instruction, okay, we simply do this. If we were going to add an instruction here, let me just show you how we did it, and I'll just rebuild it. Actually, I'll just do this. It's just easier to do it here. I'm going to insert a rung before the cursor. I'm going to delete this row. It's gone. And I'm just going to go, well, we had X1. We can just type that. Counter. I'm going to drag that here. Counter number CT1. Set point 12 or whatever I want. You see it's done that. I'm going to leave these alone. Now it creates a sub row, if you will, right here. And I'm going to click here and I'm going to type X3. I don't have to drag the normally open. Could. And I'm going to hold down the Control key. And then I'm going to go right arrow. It connects me all the way to column AF. What's column AF? We haven't really needed it as much, but you know, we're able to see that it makes it nice and tight here. So if we did tell it to show all the other rows, which I'm not going to do right now, we would see that there's or columns, there's C, D, E, F, etc. So now I've edited this program. I'm going to go to the PLC menu, write it into the PLC, because once I've changed it, it won't let me use that. I've got my program how I want. I'm going to hit OK. Take out the unit out of run. Transfer is complete. Go back into run, and we see it's retained that value, and I can continue to use this program. So that's how you input a counter. This is an example. You're going to prove the same thing in lab. And this ends this video. Thank you for watching.